another example here, which is considering if we have the mass of 15.8 grams of KClO3, how many grams of our potassium chloride, KCl, is formed or obtained, okay? So now we're gonna start with 15.8 grams and convert it to grams of KCl. We're gonna use the same equation, so I'm not gonna erase the equation. Okay. So now we're doing a different problem. So we're no longer working with 28 grams. So I'm going to erase that part here. We're going to keep this equation. Okay, so now what is our plan? Our plan here is now we're considering we have a certain amount of KClO3. Why am I removing that? And now we're converting it to KCl. So we're going to be looking at the relationship, the mole relationship between KClO3 and KCl. Okay. What you may be noticing is that it's a 2-to-2 mole ratio, which is almost like a 1-to-1, right? But even if we have a 1-to-1 mole ratio, we still have to show the calculation of changing the substance, okay? So even if it's just multiplying by 1, it still has to be written out because what we're doing is we're changing to a different substance, okay? So before we get to that, I know I got ahead of myself there. We are starting with 15.8 grams of KClO3. We must convert to moles first of KClO3. Once we get to moles of KClO3, we can convert to moles of KCl using the mole-to-mole ratio, 2-to-2 mole ratio. Then from moles of KCl, we can get to grams of KCl. That's our plan. So I had erased the molar mass of KClO3, but I believe it was 122 122.6. So we're going to start here with 15.8 grams. 15.8 grams of KClO3. The first step we must take is to change it to moles. We use the molar mass in that step. Okay, so we said the molar mass was 122.6 grams of KClO3 per 1 mole of KClO3. Cancel the units of grams. Now that we have moles of KClO3, we're at this step, we're going to go to moles of KCl. The mole-to-mole ratio is 2-to-2. So that's telling us for every 2 moles of KClO3 that reacts, 2 moles of KCl is formed, okay? But we don't want moles, remember? We want grams. So we have one step further to go. Now we need the molar mass of KCl. Molar mass again. We said that potassium is 39.1. We said chlorine is 35.5 from the periodic table. Add those masses together. We get 74.6. 74.6 grams of KCl per 1 mole of KCl. Cancel out your moles of KCl, and guess what we're left with? Grams of KCl, which is what is our desired units. Remember to focus on the units before you grab your calculator. Now that we have everything set up and canceled, and we got to our desired unit, now we do our math. 15.8 divided by 122.6 times 2 divided by 2 times 74.6. And what you should be seeing in your answer, 3 significant figures, so round it to 9.61 grams of KCl. We have one more example to do together to finish this part of our video series. And then after we do this last example, our next video will start into the chapter 7 material. Okay. So let's go back to the PowerPoint here. Okay. And this is going to be the problem we're going to work on next. I'm going to erase the board quick. I just want to make sure you guys had enough time to have, well, you guys can pause the video and do everything that you need. So I always forget that since this is pre-recorded, at any point in my video, you can pause me to watch the board, okay? I try to make sure I'm out of the way so you guys have the moment to kind of pause and keep looking at the board. I hope that I've been successful in doing that. But anyways, so this is our next problem that we're going to consider with practice to convert from grams to grams, okay? So, whoops, I changed the name again. I had edited the problem earlier and then I didn't change the name. I wanted to keep names that we're familiar with so that there's not extra confusion. Okay. Okay. So the following reaction produces 0.022 grams of calcium carbonate. What mass of calcium chloride was used as the reactant? So we want to know how much is needed. So we're doing the opposite. So we can still do the same calculations, no matter if we are starting with the amount of reactants or starting with the amount that's produced, okay? We want to know how much was needed to start with in order to produce a certain amount of our product, in this case, calcium carbonate, okay? So we are producing 0.022 grams of calcium carbonate. So that sounds very small, but we're just going to go with the number right now. What mass of calcium chloride was needed to produce that amount of calcium carbonate? It then gives you already the molar mass of calcium carbonate and the molar mass of calcium chloride. Okay, so our first step, always, you must make sure you have a balanced equation. So looking at this equation here, I'm going to look at this and I'm going to say this does not look like a balanced equation. The main things that I'm recognizing as not balanced is the chlorine and the sodium on both sides. So that's the first thing that we're going to work on together, is to balance the chemical equation. Then it's asking you to identify your conversion factors that are needed. using molar masses and mole ratios, and then set up your dimensional analysis. Okay. So I'm going to switch over and start getting this written out, starting with the chemical equation. Calcium chloride, we're going to say this was aqueous, I believe. So this is happening in solution, aqueous. When calcium chloride reacts with sodium carbonate in solution, what forms, I'm going to run out of space actually. Hold on 1 minute. I'm going to bring this down. CaCl2. Sorry, these markers dry up really quickly. CaCl2. Aqueous is reacting with sodium carbonate, which is Na2CO3 aqueous, to form calcium carbonate, which becomes a solid, and sodium chloride, which is in solution. Okay, looking at this, what I noticed first is that there's 2 chlorines here on the left and only 1 on the right. So I'm going to put a 2 in front of the NaCl. Then when you see that, I now have 2 sodiums on the right, 2 sodiums on the left, 1 calcium on the left, 1 calcium on the right, 1 carbonate is here on the left, 1 carbonate is on the right. This reaction is now balanced, okay? So what this reaction is saying that 1 mole of calcium chloride is reacting with 1 mole of sodium carbonate to form 1 mole of calcium carbonate and 2 moles of sodium chloride, okay? But our question is saying that we have 0.022 grams of calcium carbonate being produced. Okay. So if we are producing 0.022 grams of calcium carbonate, this is our question mark. We want to know how many grams of calcium chloride did we need to start with, okay? It's the exact same procedure. We start with the grams, 0.022 grams of calcium carbonate. Convert grams to moles of calcium carbonate. Then from moles of calcium carbonate, we use the relationship. In this case, it's just a 1-to-1, but we still need to show that we're changing our substance from calcium carbonate back to the starting material. How much calcium chloride did we need? Okay, so we're changing the units of moles of calcium carbonate to moles of calcium chloride. Then from calcium chloride, we can find the grams of calcium chloride. Okay, that's our plan. And now we're going to begin our conversion. You are given the calcium carbonate molar mass and the calcium chloride molar mass. So that helps matters. Starting with 0.022 grams of calcium carbonate, we convert to moles using the given molar mass, 100.1. per 1 mole. Cancel out the units of grams. We now have moles of calcium carbonate. From moles of calcium carbonate, we need to find out how many moles of calcium chloride reacted to form the calcium carbonate. So what we saw here, 1 mole of calcium chloride reacts to form 1 mole of calcium carbonate. So this is a 1-to-1 mole ratio, but you must still write it out because you are changing from one substance amount to a new compound. Now we're working with calcium chloride. We want to know how much calcium chloride reacted. Now from moles, we can find grams, okay? Grams of calcium chloride will be determined using the molar mass. The molar mass is given 111.0 grams per mole. 111.0 grams of calcium chloride goes on top per 1 mole of calcium chloride on the bottom. Cancel the units diagonally. And then we solve. 0.022 divided by 100.1 times it by 111. What I am getting in my calculation is 0.024 grams of calcium chloride. That's the amount of calcium chloride that would be reacted to form the calcium carbonate. Okay. So that is the last example that we're going to cover for mass-to-mass relationships within a chemical equation. The next video will then start into chapter 7.